Hello dear friends, welcome to a lecture on Gauss backward difference formula. We shall obtain or we shall derive Gauss backward difference formula in this lecture. As in our earlier lecture we have obtained Gauss forward difference formula, and the procedure to derive Gauss backward difference formula is similar to that of Gauss forward difference formula. So I suggest you to refer that lecture. We have earlier obtained Gauss forward difference formula. You refer that lecture, and the same procedure we will use to obtain Gauss backward difference formula. I have constructed the difference table here, which is the same as in the earlier Gauss forward difference formula. The columns are of x, y. These are the tabulated values given, x and y values, and then we have constructed the differences for these, and delta and higher order differences. The values of x are x minus 3, x minus 2, x minus 1, x naught, etc. As we know, these are central difference formulae, and therefore at the center we consider the values x naught and y naught, and then these are the values so before x naught, and these are the values after x naught that we have constructed in the table, or the table is formed in that way. These are the corresponding values of y, and these are the differences. Delta difference of these two values is written in between the line of these two entries, and similarly all the differences of first order are written. Second order differences of these difference of these two or subtraction of these two is written here as delta square y minus 3. That we have studied earlier, how to construct the difference table. So we directly start the formula, and here the differences are taken in this formula as this is the along the central values. X naught is the value of x, and corresponding to that y naught is the value. So we consider the differences along this arrow diagram. Y naught, then delta y minus 1, slightly upward, then inclined downward, delta square y at minus 1, then again inclined upward, then downward, then upward, inclined upward, and inclined downward. Next will be inclined upward, and so on. So thus the differences in this formula are used, these one which are along this arrow diagram. So we let consider xp, let yp be the value, be the value of y, or be the ordinate, we can say ordinate at x is equal to xp, where we have xp as this is the same as in Gauss forward difference formula. Xp is equal to x naught plus ph, where h is the difference between the values of x which are equally spaced, and therefore this gives the expression for p as xp minus x naught divided by h. Generally the Gauss difference formula, in Gauss backward difference formula, p should be between say minus 0.5 is less than p is less than 0, preferably. It is not rigid or it is not fixed. It may be other than p, may be sometimes positively taken, but usually we should consider the value of p between minus 0.5 to 0. Now the differences in this table, in this formula, that means Gauss backward difference formula, are along the arrows in the difference table. So this is to be remembered, the arrow diagram, or that means the differences, how the differences are taken is to be remembered, and therefore the formula is Formula is of the form yp is equal to y naught first term plus g1 dash delta y minus 1. G1 dash we are using in Gauss forward difference formula, we have used G1, G2, etc., and therefore to make the difference I have considered here G1 dash plus G2 dash or G2 prime delta square. After delta y minus 1, delta square y minus 1 plus G3 dash delta cube c y minus 2 plus G4 dash delta power 4 y minus 2 plus G5 dash delta power 5 y minus 3 and so on. It's continued. If there are n plus 1 entries of x, then the differences are required to be considered as up to nth order, and this is the formula we have considered where, and now you see that the values of g1, g2, etc., g1 dash etc. are to be determined, where g1 prime, g2 prime, g3 prime, g4 prime, etc. are to be determined. Now, how these are determined? We have done this procedure in Gauss forward difference formula. We have written the expression for yp using Newton's forward difference formula, and that means in terms of y naught delta square y naught, etc. And we have also written this each difference on RHS delta y minus 1 in terms of y naught delta square y naught, etc. So these differences are written, and then the values on both sides are put in this equation 1, and we have equated the coefficients of delta y naught, delta square y naught, delta cube y naught, different powers of delta on either side to get g1 dash, g2 dash, g3 dash, etc. You may please refer the Gauss forward difference formula, derivation of Gauss forward difference formula, how these values of g1, g2, etc. are obtained. And likewise, see, using the same procedure as in, I shall mention here only, using the same procedure as in Gauss forward difference formula, as in derivation of Gauss forward difference formula, we get, see, I shall write now directly the values of g1 dash, etc. We get g1 dash is equal to p, g2 dash is equal to p plus 1 into p divided by 2 factorial, g3 dash is equal to, see, p plus 1 into p minus 1 divided by 3 factorial, g4 dash is equal to, after taking p plus 1 2 times, we shall consider p plus 1 2 times, we shall consider p plus 2, p plus 1, these terms decrease by 1, p plus 2, starting with p plus 2, p plus 1, then p, 4 terms we should write, and last is p minus 1 divided by 4 factorial. Likewise, what will be g5 dash is p plus 2, starting with p plus 2 again. There are 5 terms in decreasing order, p plus 1, p p minus 1 p minus 2 divided by pi factorial and so on. So put this in 1, we get the formula. So I shall write the formula here, Gauss backward difference formula. Putting these in 1, we get see, it is yp is equal to y naught plus p delta y minus 1 plus g2 is p plus 1 into p divided by 2 factorial delta square y minus 1 plus p plus 1 into p minus 1 divided by 3 factorial delta cube y minus 2 c, and plus next is p plus 2 into p minus 1 into p minus 2. There are 4 terms. It is here p plus 2, here we have to correct it, p plus 2 p plus 1 p into p minus 1 divided by 4 factorial, this value, into this is g4 delta raised to 4 y minus 2, and plus so on. G dash phi can also be written like this, plus dot. So this is Gauss backward difference formula that we have obtained. So this is Gauss backward difference formula. Now we shall solve a problem on it. So I shall write a problem and then we shall solve it. I have written first problem here. The problem is using Gauss backward formula, find the population for the year 1928 using the following table. Here year wise population is given, and here the population is in thousands. That means in the year 1901 the population is 12,000. In the year 1911 the population is 15,000, and so on. So we are asked to find the population for the year 1928, and we use the Gauss backward difference formula which we have just derived, and I have written here. One more term is written. We have obtained g5 dash also, and that the terms are to be remembered as y naught plus p delta y minus 1, then p plus 1 into p divided by 2 factorial delta square y minus 1, 2 terms of y minus 1, then 2 terms of y minus 2, and then next will be 2 terms of y minus 3, etc. Well, up to 5th order we have written the terms, because there are 6 entries are given, and therefore the 5th difference will be constant, and their next differences will be, higher differences will be 0. So that's why the formula is written up to this term. And now I have constructed the difference table, some part of the table here. We have written the value of year as x and population in thousand as y. Now we shall find out the next differences, and this difference is 15 minus 12, that is 3, this is 5, this is 7, I may verify this, and this is 12. We have to write in between this, and this is you see 13. We have to check it. Yes, it is 13. And now the second order differences is 2, this is again 2, this is 5, and this is 1. Third order differences, difference of these two is 0, this is 3, this is 1 minus 5, which is minus 4, and fourth is now 3 minus 0 is 3, minus 4 minus 3, that is minus 7, and this is last one is minus 7 minus 3 is minus 10. So these are the differences. Now which value we have to select? Now the central value, that is x naught, and see the year is 1928, and that is close to this value. So therefore we shall select this as x naught, and usually the convention is for when we use Gauss backward formula, p should be negative and between minus 0.5 to 0, and that means the value to be estimated lies below the central value. And for forward formula, the value is slightly greater than the central value. This is the choice, but it is not fixed. We may consider the further sometimes the next value, or that is value slightly greater than the central value, is also selected in Gauss backward formula. And now what we shall do is we first find the value of p, selecting these values as x naught. So we have written this data in the table, so I shall rub this part. What is x naught we have considered is 1931, estimate to be obtained for 1928. So let x naught is equal to 1931, and therefore y naught is the corresponding value, that is 27 in thousands. We have to remember this unit is in thousand, and xp is that xp is 1928 to be obtained. This year's population we have to obtain, and therefore we have xp is equal to xp minus x naught, or xp is equal to x naught plus ph. P we shall find out to be used in this formula, and that is xp is 1928 and this is 1931, and plus p into h is the difference between the values of consecutive values of x, that is 10, and therefore this gives p is equal to, this is minus 3 on this side divided by 10, that is minus 3 by 10, or which is minus 0.3 is the value of p. Now we shall have to consider the differences for Gauss backward difference formula as this as y naught, then it is slightly upward, then slightly downward. This is delta y minus 1, this is delta square, according to that delta square y minus 1, then slightly upward, slightly downward, and slightly upwards. So here it stops. So thus these are the values of the differences on the right side of the formula. So using these differences in Gauss, using this value of p and the differences from the table in Gauss backward formula, we get putting the values, value of p and differences shown by arrow. Arrows in the diagram in the difference table. In Gauss difference backward difference formula, or we may suppose this as 1. In 1 we get now see, it is y at p, means the required value is equal to y naught 27 plus p is minus 0.3, and delta y minus 1 is 7 plus p plus 1 minus 0.3 plus 1 is 0.7 into p is minus 0.3 divided by 2, delta square. See, this value is 5. The values will be obtained consecutively according to this arrow. Plus, next is you see p plus 1, that is 0.7, p is minus 0.3, p minus 1, that is minus 1.3, divided by 6 into delta cube y minus 3, that is 3, plus next value is p plus 2. P plus 2 will be 1.7, then p plus 1, that is 0.7, then p is, and this value, divided by 4 factorial, that is 24, into this value, fourth difference is minus 7. And now the next term, last difference is plus p plus 2 again, and that is 1.7. Then these will be the same, 1.7. Then see, p plus 1 is 0.7, p is minus 0.3, p minus 1 is minus 1.3, p minus 2 is minus 2.3. Yes, divided by 5 factorial, that is 120, and multiplied by minus 10. So thus we have put the values of p and these differences in the Gauss backward difference formula. And now the remaining is the step of part of calculation. We have to use a scientific calculator to obtain this, to do this calculation, and the calculation I have done here. The values, this is 27, this product is minus 2.1. Next is, I shall write directly, you should verify this. So this is 0.0889525. These are the values, terms are separately calculated, and I have written the values, and now the final sum will be equal to, this is equal to 24.46509. So thus this is the population in thousands, and the answer is this, the population for the year 1928 is the estimated population for the year is this is 24.46509 thousands, because y values we have considered in thousands, or that is approximately 24,466. We shall increase this 400, see 2446 up to 5 decimal places we should consider, 465, and this 0 we will write as 1. So 24,460, 24,000, see in thousands if you write, then it is up to 5. So this is the population for the year 1928. Now I shall give you a problem for your practice. I have written this problem for your practice. Use Gauss backward, not forward, backward difference formula to find y28 given these values, y at 20, y at 25, y at 30, 35 and 40. Now we should consider the values of x as see these values. Form a table having column x and y, and x values are given as 20, 25, 30, 35, etc., and corresponding are the y values. So we need to find y28. So x and y are to be written as 20, 25, etc., 35, and then 40. So these are the values. So 5 values are given, and we have to estimate y at 28. So therefore 28 lies near to 30 and below 30. So we take this as x naught. Take this as x naught, and corresponding value will be this will be y naught. Construct the table, and then we have to take x naught as 30. See, xp is 28, and therefore xp is equal to x naught plus ph. That is 28 is equal to 30 plus p into h. H is 10. The difference of these values, not 10 but 5, and therefore this will be minus 2 is equal to 5p, and p is equal to minus 2 by 5, or which is minus 0.4. This is the value of p. Use the value of p, construct the table, use the values of differences as that we have shown in the earlier table, and solve this problem. The answer I have written is here. This value is the answer up to 4 decimal places, and that is approximated to this value. Or we make a because all these values are given in 5 digits, so this can be approximated in 5 digits. Thank you for watching the lecture.